A few weeks back, India woke up to surprising news on a Monday morning. The Vedanta Foxconn joint venture, which had plans to build the highly sought after semiconductor fabs, had called it quits. Media headlines suggested this could be a significant setback for India's ambitious semiconductor manufacturing plans. But is that really the case? Semiconductors play a critical role in electronic devices across various industries, from healthcare to cutting edge technologies like the AI. The recent disruptions in supply chains made it evident that diversifying supply chain partners and bolstering domestic and manufacturing is crucial, and India has also recognized this importance. Though India might have missed the boat during the initial semiconductor revolution, it is now eager to catch up. The government is actively working to create a robust semiconductor industry within the country, aiming to reduce dependence on its imports to meet semiconductor demands. The big question is, has this effort been fruitful? What reforms has the government implemented, and how has the response been so far? Can India truly achieve self-dependence and even emerge as a global semiconductor powerhouse? Let's begin. You're watching Informed Investor, the third empire, and initiated by Research and Ranking. Semiconductor chips have been the talk of the town since the pandemic. These teeny tiny chips are integral and are considered the brains of modern electronics. And these weren't noticed by the public until there was a shortage as a result of COVID lockdowns, which impacted several products, leading to unavailability or increased lead times. For example, due to shortage of chips, electronic items like the PS5, which were in high demand during the pandemic, were being sold at a premium or were unavailable due to limited stock. Likewise, Maruti Suzuki had to cut down its December output by 30% due to the semiconductor shortage during peak COVID period. This chip shortage indeed short-circuited the world, highlighting the vulnerability of countries relying on external sources for the supply. As a result, several nations have initiated efforts to establish or expand domestic semiconductor manufacturing capabilities to ensure a more stable and secure supply chain. While we talk about this later, let's understand the importance and application of semiconductors in several industries. The impact that semiconductors have on the world development probably exceeds that of industrial revolution. Machines, great and small, rely on semiconductor chips that are mounted inside many electronic appliances in the form of an integrated circuit that support our everyday lives. These perform the most basic to the most complex functions and make our lives easier and convenient. Semiconductors have driven advances in communications, computing, healthcare, military systems, transportation, clean energy, and countless other applications. And they are giving rise to new technologies that hold the promise to transform society for the better, including brain-inspired computing, virtual reality, the Internet of Things, energy-efficient sensing, automated devices, robotics, and artificial intelligence. The demand for chips has been skyrocketing, with the industry seeing numerous opportunities while the supply seems to be a matter of worry. And to add to that, the Indian semiconductor market was valued at approximately $23.2 billion in 2021 and is projected to reach $64.1 billion and ultimately $80.3 billion by 2028, growing at a compounded annual growth rate of 17% during the forecasted period. The rapid expansion of the market is due to the rising demand for consumer electronic products. Advanced technologies such as artificial intelligence, machine learning, the Internet of Things, and wired and wireless communications have also emerged, propelling the demand for the Indian semiconductor market. India is poised to be the second largest market in the world in terms of scale and growing demand for semiconductor components across several industries and applications such as mobile and wearables, IT, consumer electronics, industrial, telecom, aerospace, defense, and lastly automotives. While the country is becoming one of the largest consumers of electronic and semiconductor components, most components are often imported, thereby offering limited economic opportunities for the country. As per a study, only 9% of the semiconductor requirements is met locally. In a bid to further support semiconductor research and development in India, the government announced a hefty 76,000 crore rupees PLI scheme, which is approximately $10 billion, demonstrating the government's intention to establish a foothold in the semiconductor market. This was then changed last year in September to attract global investors with more incentive support. Moreover, the previous scheme offered incentives with varying degrees of fiscal support ranging from 30 to 50%. But this was changed and later made uniform, with the government offering to fund 50% of the project cost across all technology nodes for setting up semiconductor fabs, including not just cutting-edge computing chips but also those used in power, telecom and automotive sectors. Additionally, under the same scheme, it also launched the Design-Linked Incentive Scheme. Under the DLI, the government will provide financial incentives and design infrastructure to domestic companies, startups and MSMEs focused on semicon design, hoping that the scheme will create room for innovation and design of integrated circuits, chipsets, system on chips and system and IP cores. This thereby made the incentive package policy extremely competitive and the ability to attract investment from both domestic and international companies. Global companies have been exploring India as a viable investment destination for semiconductors. As the world moves away from China after too much dependence and concentration on a single country, India is positioning itself as among the most attractive destinations for setting up fabrication plants, assembly units, development and testing centers, and so on. The semiconductor industry is experiencing a significant shift in collaborative innovation, particularly with leading American companies showing strong interest in supporting India's semiconductor growth. This partnership between India and the United States aims to enhance the resilience and diversification of semiconductor supply chains, making the beginning of a new era of cooperation. Micron Technology, a major chip maker, has confirmed a substantial investment of over $800 million to build a new semiconductor assembly and test facility in Gujarat, India. This move could potentially reshape the country's semiconductor landscape and generate numerous high-tech and construction jobs. Applied Materials, a renowned company in materials engineering solutions for chip and display production, plans to establish a collaborative engineering center in Bengaluru, India. The center will serve as a hub for engineers, suppliers, research institutions, and academic organizations to collaborate on semiconductor equipment development while also contributing to talent training and development in the industry. Lam Research Corporation has committed to training the next generation of semiconductor engineers in India, with a program aiming to educate up to 60,000 Indian engineers in nanotechnologies over a 10-year period. This initiative supports India's goals in semiconductor education and workforce development. The US Semiconductor Industry Association and India Electronic Semiconductor Association have jointly released an interim readiness assessment to identify opportunities and facilitate strategic development in the complementary semiconductor ecosystems. Moreover, after withdrawing the massive $19.5 billion partnership with Vedanta, Foxconn, the world's largest contract electronics manufacturer, is investing $600 million in India, which will be spread across two projects. The first one being to set up an iPhone component facility worth $350 million and the remaining $250 million in partnership with Applied Materials to make chip making tools. The iPhone component factory is expected to generate over 12,000 jobs. Additionally, Advanced Micro Devices, a prominent US chip maker, has pledged a $400 million investment in India over the next 5 years, establishing its largest research and development design center in Bengaluru. While there is enthusiasm about these investments and India's potential in the semiconductor sector, notable companies like TSMC, Samsung, and Intel have yet to propose setting up silicon fabrication units in the country. Nevertheless, the active interest of leading global companies and FDI in establishing manufacturing facilities in India reflects progress and indicates the country's opportunity to enter the global semiconductor value chain and potentially lead the race. It is worth noting that the semiconductor industry's growth is not limited to India but countries worldwide, especially in Europe, which are keen to shift the trade balance away from East Asia. Countries all across the globe have introduced policies and reforms to induce and encourage companies to scale up and add the semiconductor value chain. With emerging technologies like artificial intelligence, 5G, and robotics driving demand for semiconductors, the industry is expected to grow significantly in the coming years. However, it's essential to recognize that the semiconductor sector requires heavy investments, and tangible results may take several years to materialize. Persistence will be key in this long and transformative journey. India's ambitions in the semiconductor manufacturing arena are put to test by a multitude of challenges. One of the key hurdles lies in the complex value chain, where chip design demands extensive research and development alongside stringent intellectual property protection, making collaboration with Indian companies a daunting task due to inadequate enforcement measures. Despite the presence of foreign companies' research divisions in the country, navigating these barriers remains a formidable challenge. Moreover, the sheer magnitude of investment required to establish and maintain a semiconductor manufacturing facility is another formidable obstacle. Adding to this complexity is the need for specific raw materials like silicon, germanium, and gallium arsenide, which must be imported, further straining the supply chain. Infrastructure limitations also pose a significant concern. India grapples with intermittent power outages and water scarcity, both of which are crucial for chip fabrication process. The requirement of hundreds of gallons of water not only contributes to higher costs but also raises environmental sustainability concerns. In addition to these fundamental issues, the semiconductor industry operates in a dynamic landscape categorized by constant price pressures from global competitors and the ever evolving technological innovations. The absence of long term stable policies further complicates matters, making it difficult for businesses to plan and invest with confidence. Lastly, a key bottleneck is that just 3 or 4 foundries account for the majority of global chip fabrication. An estimated 91% of the contract based chip making business happens in Asia between Taiwan and South Korea, with Taiwan Semiconductor Manufacturing Company and Samsung respectively. While Taiwan and South Korea are market leaders in the semiconductor manufacturing foundry space, which also has barriers to enter due to the vast amount of resources required, it will indeed take a considerable amount of time for India to show its position and dominance. Seeing the progress that is being made in the semiconductor industry and the support which the government is extending indicates that India will catch the bus which it had failed to catch in the past. India's semiconductor market is treading on the path of growth driven by the rising demand for electronic devices and the growing focus on domestic manufacturing. Owing to the emergence of new trends and collaborations with global players, investment by Indian semiconductor players with an increase in research and development and intellectual properties, the Indian semiconductor market is set to scale new heights. With that, this is me, Rahul Hassan, signing off. Have a great day and stay safe.
Did you like watching this video? Then download our app, Informed Investor, to watch more such informative and interesting videos.